Hi folks, today we get to start our unit on triangles. So the first set of notes today that we have is talking about angles of triangles and what they mean and the relationship between them, and so we're talking about angles of triangles today. We're going to start out with a theorem that's pretty important. You're going to use it as justification a lot, so you do need to know it. It says, and there's a word we need to insert here, the sum of the measures of the, should be interior, the sum of the measures of the interior angles of a triangle, so the ones that are inside of the triangle, all three of them, is 180 degrees. And this is something that a lot of you know from intermediate school, but it's something that you might have either forgotten or perhaps you feel like you never learned it at all, but this is the Triangle Sum Theorem, that the sum of, we don't want to say A and B, so we can't say A plus B plus C. That's not a thing. We can't do that. But we can say the measure of angle A plus the measure of angle B plus the measure of angle C. So all of the measures, all of the values of degrees is equal to 180 degrees. So if you haven't had feedback on an assignment yet that talks about the measure of an angle being a certain number of degrees and not the angle itself, then this is something that you want to pay attention to, because you can never have an amount of degrees that an angle is equal to. It always has to be the measure of an angle, or the sum of the measures of the angles. So this angle measurement plus this angle measurement plus this angle measurement all equal 180 degrees total. So there are some corollaries. A corollary is a theorem whose proof follows directly from another theorem. So it's kind of like a secondary theorem. So the first corollary that we have is the acute angles, so the angles that measure less than 90 degrees. The acute angles of a right triangle are complementary. Not complementary as in you get a free drink, complementary as in the sum is 90 degrees. And here's the reason behind it. We know that the sum of the measures of the interior angles of a triangle is 180 degrees. So that means that this measure, which is 90 degrees, plus the measure of angle D, plus the measure of angle E, has to equal 180 degrees. Well, if I subtract this 90 degrees from both sides, I'm going to get that this sum has to equal 90 degrees. So angle D and angle E are complementary. That means that the measure of angle D plus the measure of angle E equals 90 degrees. So we've got to have 90 plus these two, which also equal 90, to equal the full 180 degrees for the interior angles of a triangle. Next corollary, the measures of each angle of an equiangular triangle, equiangular meaning equal angle measures. So angles A, B, and C all have the same measure. So the measure of each angle of an equiangular triangle is 60 degrees. So the measure of angle A equals the measure of angle B equals the measure of angle C. Those all have to be equal to 60 degrees, and here's why. Let's say that this measurement is x degrees. Well, if our triangle is equiangular, that means that angles A, B, and C all have degree measures of x degrees. So if I add x plus x plus x, and I set it equal to 180 degrees, that's 3x equal to 180 degrees. I realize I'm off of my screen here. And then if I divide by 3, I get an x value of 60. So that's where this comes from. Okay, so I'm going to go ahead and move this up. We're going to look at our first figure. It says find the measure of each angle. I've got some angle measures here, but then I also have angle 1, angle 2, and angle 3 that I have to find the measures of. So I'm going to need the measure of angle 1, the measure of angle 2, and the measure of angle 3. Those are all going to be answers that I need before I can finish my problem. So let's look at angle 1, because it's angle 1, first one. So I notice that angle 1 and this 57 degree angle, angle KLM, this one right here, they are together and they create a line and they are adjacent. So that means that these are a linear pair. And a pair of angles that are creating a linear pair have to add to be how many degrees? They have to add to be 180 degrees. So the measure of angle 1 plus 57 equals 180 because linear pair implies supplementary. Oops, squeeze that in. So if I'm solving for the measure of angle 1, then I can go ahead and subtract my constant here, minus 57. And I get the measure of angle 1 is equal to 123 degrees. Okay, so 123 degrees. Now, our notes today over angles of triangles start out with the Triangle Sum Theorem. Remember, the Triangle Sum Theorem talks about the interior angle measures of a triangle, and the sum of the interior angles of a triangle should be 180 degrees. So if I know this is 71 degrees and this is 57 degrees, whatever this is has to add to these two to be 180 degrees. So I can create another equation for my missing measure of angle 2. So the measure of angle 2 plus 57 plus 71 must equal 180 total degrees, and that's the Triangle Sum Theorem. That's our justification. So take a moment to solve for the measure of angle 2. You should get an angle measure for angle 2 of 52 degrees. And then finally, if you look at the measure of angle 3, that missing angle 3 measurement, we've got a 123 degree angle, which we found at the beginning. We have a 28 degree angle, and then we have a missing angle measure. So by the Triangle Sum Theorem, I should be able to add all of these up and set them equal to 180 degrees. So I'd like for you to pause your video, set up the equation, and try to solve for the missing measure of angle 3. Check the equation. Check your justification. The sum of the 3 interior angles of a triangle must equal 180 degrees. Check your math and check your answer. The measure of angle 3 should be 29 degrees. I'm going to change to my next page. The next page starts out with a problem that again says find the measure of each angle. We have angles 1 and 4. We have angles 2 and 3. So I'm going to go ahead and make myself a little area for my answers over here. There we go. Okay. So let's look at our missing angle measures, and let's try to see which angle has 2 other angles in the triangle that are already marked with a certain amount of degrees. So for example, angle 3 and angle 4, both of those are unknowns, and we know this angle measurement right here. What is this? If this is 90 degrees and it makes a linear pair, then this must also be 90 degrees. So we only know one angle measure here, not these two. So those are going to have to wait. But look at angle 1. We have a 52 degree angle here and a 90 degree angle here. That means this is the only unknown within that set of 3 interior angles of a triangle. So I can use the Triangle Sum Theorem to create an equation out of these 3. So take a moment to try to do that. Set up an equation for the measure of angle 1 and try to solve for the measure of angle 1. Pause your video. So I want to point out 2 possible equations that you wrote that would be correct. The first one is the measure of angle 1 plus 52 plus 90 equals 180 degrees. That's by the Triangle Sum Theorem. And we're talking about triangle TYZ right here. It is also possible that you wrote the equation that the measure of angle 1 plus 52 equals 90, and that's from that first corollary that says that the acute angles of a right triangle are complementary. So acute angles of right triangle are complementary. So either of those equations are correct. They both guide you to the angle measure for angle degrees. So, hang on. My lights turned out. Okay. So, knowing what you know about how to get the measure of angle 1, why don't you try to find the measure of angle 2? That might lead you to the measure of angle 3, which might lead you to the measure of angle 4. So try to get as far as you can with respect to your remaining 3 answers. Pause your video and try it out. So the pink is how to find the measure of angle 2. So if you add 38 and the missing measure of angle 2, those two are the acute angles of a right triangle. So you should be able to set them equal to 90 degrees. You have the measure of angle 2 equals 42 degrees. You know that angles 3 and 4 together make a right angle, so they're complementary. If you add the measure of angle 3 plus the measure of angle 2, which we found to be 42 degrees, you can set it equal to 90 and solve. And then finally here in triangle TZW, you have angle 4 and angle 3's measures. If you add them together, they should equal 90 degrees since they're the acute angles of a right triangle. So the measure of angle 4 plus the measure of angle 3, which was 38 degrees, should equal 90, and you get the missing measurement of angle 4. So a lot of times in problems like this, if you can get one piece, then that leads to the next piece, which leads to the next piece. So it's kind of like a puzzle. So let's go ahead and shift down to the exterior angle theorem. The exterior angle theorem states that the measure of an exterior angle of a triangle, so it's talking about this right here, exterior meaning on the outside, so this angle measure right here. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Remote interior angles. So the remote interior angles it's talking about are angles 1 and 2. Those are the remote interior angles. If you are not sure how to remember this, think about remote in the way that you think a remote is. Remote means from a distance. Like right now, virtual students, you are learning remotely. Or if you're watching TV and you have the remote from the couch, you can change the channel. So that means from a distance. So when it's talking about the remote interior angles, there are 3 interior angles, but the 2 that are the remote are the ones that are really far away from the exterior angle that you're talking about. So not angle 3 because it's close here, but angles 2 and angles 1 are the remote interior angles from this exterior angle right here. So the exterior angle theorem says that if I have the measure of angle 4 that I'm looking for, I can find it by taking the measure of angle 1 plus the measure of angle 2. So if I add these 2 together, it should equal this amount. So let's see that in an example. It asks us to find the measure of angle J. The measure of angle J is right here. This is the one that we need. So we know that the exterior angle equals the sum of the 2 remote interior angles. Here's the exterior angle, so 126 equals the sum of the remote interior angles, so that would be this angle and this angle. These are the 2 that are the remote interior angles, the ones that are interior but far away from the 126 degree angle. So if I add 6x plus 1 and 5x plus 17, I should be able to set it equal to 126 degrees. So 6x plus 1 plus 5x plus 17. If I add together my like terms, that's 11x plus 18. If I subtract my constant of 18, then I end up with 1, what is that, 1 Oh, wait a second. What did I do wrong? Really look at what I wrote. What did I do wrong? This was not an intentional mistake. I actually made the mistake. What did I do? Look at this. -1, right? What did I do? +1. You think that's going to make an issue for me later on? Yeah. Because instead of 1 plus 17, it should be -1 plus 17, which instead of being plus 18, should be plus 16. So now whenever I move the constant, I'm not moving 18, I'm moving 16. So 110 equals 11x. And if I divide by 11, I should get an x value of 10. Which is great, but this is not what I was asked to find. I was asked to find the measure of angle J, which is right here. Here's the expression. So I'm going to take 10 and substitute it for x. 5 times 10 plus 17 is 50 plus 17, which is 67 degrees. That's the measure of angle J. Notice the way that I'm writing it. I'm not writing that angle J is 67 degrees. I'm not writing that J equals 67. I'm writing that the measure of angle J, so the actual amount, the number value, the measure of angle J is equal to 67 degrees. I've included my units. This is the full way to write the answer to this problem. Okay. All right, our last page of notes today. We get to talk about the third angle theorem. The third angle theorem says if two angles of one triangle are congruent, so we've got angle L and angle R congruent to each other, angle M and angle S congruent to each other. So if two angles of